Hello friends, now today we are going to see some examples on polar curves. In the last lecture we have seen what is the algorithm to trace the polar curves. Also we have seen some basic concept that we are going to need for polar curves. Okay, so already we have seen how to check the symmetry about x-axis and y-axis. So for x-axis simply replace theta by minus theta. For y-axis we are going to change both the things, replace theta by minus theta and r by minus r. Then in the next part, after symmetry, we are going to check out whether the curve is passing through pole or not. So to check the pole, what we are going to do, we are supposed to find out a value of theta for which r will become 0. Then for a tangent pole, we are going to put r is equal to 0 and corresponding values of theta we are going to find out in between 0 to 2 pi. Then for angle between tangent and the radius vector, we are going to make use of this formula tan phi is equal to r d theta by dr. Okay, and if you remember, we have seen last part is limitation. So in the limitation, we are going to find out one table for different values of theta and corresponding values of r. We are going to find out the whatever is the maximum value of r, that is the boundaries inside that our curve will lie. Okay, so let us start with the first example. So your first example is r square is equal to a square cos 2 theta. The curve that you are going to get is called as Bernoulli's lemniscate. Okay, the name of the curve is Bernoulli's lemniscate. This is the name of that curve that we are going to see. Okay, so let us start with the symmetry. So if you replace theta by minus theta over here, the cos of minus 2 theta will give you cos of 2 theta only. So there is no change in the equation. Similarly, if you replace r by minus r and theta by minus theta over here, so minus r square is r square and cos of minus theta will give you cos theta only. So again there will be no change. Therefore here in this problem we are going to have a symmetry about x-axis as well as symmetry about y-axis. So in this problem we are going to have a symmetry about both the axes. Fine. Then next thing that we are going to check is whether the curve is passing through pole or not. So you are supposed to get a value of theta which will make r is equal to 0. So for example, if you put here theta is equal to pi by 4, so what is your 2 theta? 2 theta will be pi by 2 and cos of pi by 2 is 0. That means when you put theta is equal to pi by 4, your r will become 0. So the curve will pass through pole. Okay, because we are getting one theta which is making your r equal to 0. Okay, the curve is passing through pole. Now to find out the tangent at pole, what we are going to do, we are going to equate this r to 0. So when you equate r to 0, you are going to have a square is equal to a square cos 2 theta is equal to 0. Okay, but this as I told you, a is not equal to 0. You are going to get cos of 2 theta is equal to 0. So what are the values of 2 theta which will make cos of 2 theta 0? So 2 theta we can say it is pi by 2, 3 pi by 2, 5 pi by 2 and so on. There are many values. Okay, but as I told you, we are going to get the values of theta in between 0 to 2 pi. Okay, so when you find out theta corresponding to it, it will, when you take that 2 on that side, you are going to get the values of theta as pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4 and so on. So in that we are going to check out only those values of theta which lies between 0 to 2 pi. Okay, so here I have written only 1 because of this symmetry, because since the symmetry is about both the axes, we are supposed to trace the curve only in the first quadrant. Okay, but if you want, you can write down all the tangents. The tangents are pi by 4, 3 pi by 4, then 5 pi by 4 and 7 pi by 4. Okay, so if you look at the curve by the symmetry, first of all, the symmetry is about both the axes, so it is enough. If you trace the curve in the first quadrant, that will be enough, because the same kind of thing will be there in the second quadrant. And once you have the upper part, the lower part will be again same, because symmetry is about initial line also. Okay, then the next thing is the angle between um, radius vector and the tangent. Okay, so up till now we are having like this. See, we are having that pole is passing through origin, and also we are getting a tangent at pole is at theta equal to pi by 4. Okay, so now to get this tan phi, we remember, if you remember, tan phi is the value for tan phi is nothing but what? R d theta by dr. So simply what you have to do, you have to take the derivative of this, and you have to reverse it, and you have to find out the value of r d theta by dr, and when you equate, you are going to get something like this. So what you are going to get? You are going to get phi is equal to pi by 2 plus 2 theta. Okay, now if you keep on changing the values of theta, corresponding value of phi you are going to get. For example, when you put theta is equal to 0, the corresponding value of phi will be pi by 2. Okay, so let us see that part. And also when you keep on putting the values of theta, you are going to get a different values of r, and the maximum of value of r that you are going to get is a. So here the maximum value of the radius vector is a, so our curve will be totally lie between a circle of radius a, because उसके बाहर तो कर्व नहीं जाने वाला है, तो maximum radius vector is a. Okay, so if you look at the diagram, so this is the maximum value, r is equal to a. So and at that point, if you remember, here we have seen at theta equal to 0, your phi is pi by 2. That means they at that point we are going to get a tangent. Okay, and this is a circle. This is a circle of radius a, because as I told you, this is the maximum value of r, and in which our total curve will lie. Okay, these are the values of theta that I have written only for the first quadrant because of the symmetry. So theta is equal to 0, your r will be a, and when your theta is equal to pi by 4, this is equal to 0. Okay, so this kind of curve that you are going to have, because this is also tangent, this is a tangent, and this is also tangent, so the nature of the curve at that point will be parabolic. Okay, so similar kind of thing will be there on the below the x-axis, and because of the symmetry about y-axis, the same kind of thing we are going to have on this side. So it is look like an infinity, and the name of this curve is Bernoulli's lemniscate. Okay, so let us move to the next curve. R is equal to a plus b cos theta. So here we are taking a and b as same. So what you are going to have, r is equal to a plus a cos theta, or we can say it is r equal to a into 1 plus cos theta. So if you replace theta by minus theta, what you are going to get, the equation remains unchanged, therefore the symmetry is about x-axis. But when you replace both, when you replace r by minus r and theta by minus theta, your equation will change, because this side will change. Your left hand side, instead of r, you are going to have there minus r, so it will change, therefore it is not symmetric about y-axis. Fine. So by the symmetry, you are going to get a symmetry only about x-axis. So above part you have to trace over here. Now for pole, you have to get a value of theta which will make you r equal to 0. So if you put, suppose theta is equal to pi, cos pi is minus 1, so this term will become minus a, and a minus a will give you 0. So when you put theta is equal to pi, this will work, and you are going to get r is equal to 0. Therefore curve is passing through pole. Okay, then the next thing is, as I told you, you have to find out the tan phi. Tan phi is nothing but what? It is r d theta by dr that you are supposed to find out. Okay, and the last part is r is the maximum and minimum values of r you are supposed to find out. So when you put theta is equal to 0 over here, you are going to get a plus a, that is 2a. So 2a is the maximum value of radius vector that we are going to have. Okay, so we are going to draw here a radius, a circle of radius 2a, and inside that our curve will lie. Okay, so let us see. what kind of thing you are going to have in this curve. As I told you, the curve is passing through pole. Then the next thing that we are going to have is r is equal to 2I is the maximum value of the radius. And when you put theta is equal to 0 over here, what you are going to get? When theta is 0, you are going to have tan phi is equal to, when theta is 0, tan phi is equal to infinity. That means phi is equal to pi by 2. Okay, so here we are going to have an angle between radius vector and the tangent is pi by 2. That's why it is a perpendicular line. Okay, this is the maximum value of r in which we are going to have our curve, and these are the some points where we are going to plot our point. So when theta is 0, your r is 2a. So this is the, when theta 0, this is the length of the radius vector. Then pi by 4, when you put pi by 4 over there, when theta is equal to pi by 4, what you are going to get? You are going to get r is equal to a plus a 1 by root 2. Okay, so it will be a value which is somewhat greater than a. Okay, so here your theta is equal to 0. Then this is the point when theta is equal to pi by 4. At pi by 4, you are going to get the length of the radius vector as a plus something. Okay, so see, this is the point. Then when you put theta equal to pi by 2, when you put theta equal to pi by 2, your this part will be 0, and you are going to get r is equal to a. That is, the length of radius vector will be a in that case. So this is the point, which is it should be a bit less than the previous point. Then when you put theta equal to 3 pi by 4, your value of a is a minus a by root 2. So it should be less than a. So see, it is below a. And when you put theta is equal to pi, you are going to get r is equal to 0. So it is on the origin. So when you join all these points, you are going to get this kind of thing. And a similar kind of thing is there below x-axis by the symmetry about x-axis. So this kind of curve you are going to get, and this curve is called as cardioid because it's look like a heart. Okay, so this curve is called as cardioid. Okay, then this is the last part from the polar curve, rose curve. So why it is called as a rose curve? Because we are going to get a petal over here, so it is called as a rose curve. Again, rose curve is a special case of polar curve. So again, the similar kind of algorithm we are going to apply. So symmetry about x-axis, when you replace theta by minus theta. Then about y-axis, when you replace both theta by minus theta and r by minus r. Pole, rose curve passes through pole always, because the equation of rose curve is look like r is equal to a sine cos theta or a cos a sine n theta or a cos n theta. For tangent pole, again we are going to put r is equal to 0 and we are going to find out the corresponding values of theta. Okay, then again the limitation, the maximum value of r we are going to find out. This is the shortest way to trace the rose curve. So for a rose curve, the equation of the rose curve is actually look like r is equal to a cos of n theta, or you are going to have sine of n theta there. Okay, so the n that you are going to have, depending on that n, we are going to have the number of loops. So if your n is odd, you are going to have n loops. If you are going to have n is even, then we are going to have 2n loops. So remember, for odd you are going to have exactly same number of loops. If n is even, then we are going to have a double loops in the diagram. Okay, so this kind of loop we are going to get in a rose curve. Now for drawing the loops, divide each quadrant into n equal parts. So n will be given in the problem, either 2, 3. Okay, so if it is 2, we are going to divide each quadrant into 2 equal parts. If it is 3, we are going to divide each quadrant into 3 equal parts. Now if we are having the equation of the curve like a sine n theta, then if sine is involved, we are going to draw the first loop at theta equal to pi upon 2n, and when if cos is there, we are going to plot our first loop at theta is equal to 0. If n is even, then the number of loops are more, 2n loops are there, so we are going to draw the loops in a consecutive sector. We are not going to put any sector blank. And if n is odd, draw loops in a alternate sectors. Okay, I'll tell you the sector. Sector is nothing but what? It is the area between two tangent. It's called as a sector. Okay, so let us see one example of sine and one example of cos. So here if you look at the equation, r is equal to a sine 2 theta. So here your n is what? Your n is 2. Okay, and it is even. So here we are going to have a 4 loops. Okay, in this rose curve. So it is symmetric about y-axis because when you replace theta and r both, the equation remains unchanged. So symmetry is about y-axis. Then the pole, when you put theta is equal to pi by 2, you are going to get r is equal to 0. There are many values that you can find out. So if you put theta equal to 0 also, you are going to get r is equal to 0. The curve will be passing through pole. Then for tangent pole, you are going to equate sine to theta is equal to 0, r equal to 0. That means sine to theta is equal to 0. So what are the different values of 2 theta? 0, pi, 2 pi, 4 pi, 6 pi and all. That means corresponding value of theta will be 0, pi by 2, pi and 3 pi by 2 and so on. So these are all the tangents at the pole that you are going to get, but we are going to consider only those tangents which are between 0 to 2 pi. Now when you put the different values of theta, you are going to get the maximum value of r, because the maximum value of sine is plus 1 or minus 1. So your r will be plus a is the maximum value. Now we are going to divide each quadrant into 2 equal parts because your n is 2. Number of loops will be 4. First loop at pi by 4. Okay, so your curve will look like this. See, so symmetric about y-axis. Then we are going to have curve is passing through pole. Then we are going to have theta equal to 0. This is a tangent, so green line for a tangent. Then for pi by 2 also it is a tangent. Then pi is also a tangent. This is the maximum value. R equal to a is the maximum radius that we are going to have. So we are going to draw a circle of radius a from the origin. So this is what this is. We are dividing each quadrant into 2 equal parts. Okay, so here, so if you look at the two tangents to try to understand, this is one tangent, this is one tangent. So this is nothing but your sector. This is another sector, this is another sector, this is another sector. So in this problem we are having 4 sectors, and in these 4 sectors we are going to trace the loop. And as I told you, when n is even, we are not going to keep any sector blank. So in every sector we are going to trace the curve. Okay, so this will be the first loop. And what is the length of the loop? This is r is equal to a. This is the length of that loop. Okay, and in every sector we are going to have a loop. So we are going to get these 4 loops there. This is called as a rose curve. Similarly, when you put r is equal to a cos 3 theta, again what is your n? N is 3 over here. It is odd, so we are going to have only 3 loops over here in this problem. Symmetry is about x-axis because when you replace theta by minus theta, equation remains unchanged. Passing through pole, because when you put theta is equal to pi by 2, you are going to get cos 3 pi by 2 0. So it is passing through pole. When you equate cos through theta to 0, you are going to get 3 theta is equal to pi by 2, 3 pi by 2, pi by 2 and so on. So corresponding values of theta will be pi by 6, pi by 2, 5 pi by 6 and so on. These are nothing but what? These are the tangents at the pole. Okay. For limitation, when the maximum value of cos will be plus 1, minus 1, so r will be plus a maximum, minimum it will be minus your 0. So since n is 3, we are going to divide each quadrant into 3 equal parts. three loops we are going to have, and the first loop at theta equal to 0. So your diagram or your rose curve will look like this. Symmetry is about x-axis, then pole is passing through origin, or the curve is passing through pole, sorry. Then this is the tangent. First pi by 6 is the first tangent, then the next tangent is pi by 2. This is the pi by 2 line. Then next is 5 pi by 6. These are the tangents. The lines in green represent the tangents. This is the circle of radius A. So inside this we are going to have the curve, and the length of the loop that you are going to take is r is equal to A. Okay. So these brown lines, we are actually dividing the coordinate into three equal parts. 1, 2, 3. 1, 2, 3, and so on. One more line we have to draw. Okay, so this will give you equal parts. Now what are the sectors? Sectors are nothing but what? This part, this part, this part, this part, this part, this part. So the region between two tangents are called as a sector. Okay, so these are the, I'm simply adding, keep on adding pi by 6 there, and you are going to get that points. Okay, so first loop at theta equal to 0, then keep the next sector blank, go do it in the next one, keep the next blank, do it the next one, keep the next blank. Okay, because when n is odd, the number of loops are less, so we are keeping one sector blank. Okay, so that's it for today. We'll stop here. So please practice all the problems. Okay, thank you.